All right, to find the molar mass is exactly the same thing as finding gram formula mass. It's the mass of 1 mole of a substance. So what I did was I looked up the atomic masses of barium, multiplied it by 1. Oxygen was 16 multiplied by 2, got me 32. So let's just point a pointer here, 32. 2 times 1 is 2. Added them all up, I got 171. Now, see how this is 171.3? That's because we rounded something in here that they didn't. But none of the other answers are even close. So we have to have 171.3 be our answer. All right, in question number 2, we're calculating the number of moles. Let's break out a highlighter here, number of moles. So we're going to need the mole formula. We have a 12-gram sample, and my formula is Cl2. All right, we're looking for moles. So that's my X. Grams is 12. So I'm going to put 12.0 grams on top. And my gram formula mass for chlorine, there's 2 of them at 35.5 apiece, or 35 because I'm rounding it down. So that gives me 70 grams per mole. I should put my units in there so everybody knows what I'm talking about. 70 grams per mole. And I have to do X equals 12 divided by 70. My answer is 0.17 moles of Cl2. Now, my question over here does not give me an option of the actual answer. It actually gives me the setup. So we have to find the one that's 12 over 70. This one right here is 12 over 71, which means they left the 35.5 and left it as 35.5, and so when they multiplied 35.5 times 2, they got 71 here instead of 70. So don't worry about being off that tiny itty bitty bit. All right, in this question, we're asked for how many moles. So once again, we need our mole formula, where we're actually going to be looking for moles. They gave us 49 grams, so that goes on top, 49 grams. And we need the gram formula mass of the only formula that they gave us, which is H2SO4. I calculated the gram formula mass, which I got right down here, which is 98 grams per mole. So 49 divided by 98 is 0.5 moles of H2SO4. 0.5 moles is answer choice 1. All right, in this question, they're asking us what is the mass. And remember, when they ask you for mass, oops, that's sloppy, they're really asking you for grams. So we're going to write down our formula, moles equals grams over gram formula mass. And what they're actually looking for is this. So we're going to go X over, they gave us moles, 3.45, so we'll put 3.45 moles here. I ran out of room to write the units. And I need the gram formula mass of NH4NO3, which is ammonium nitrate. So I went ahead and I wrote everything out. Now be careful, in this particular case, let me grab a highlighter here, there are 2 N's. So you have to make sure that you have 2 N's there, and you multiply them by 14, and then we got the H's and the O's. Add all those bad boys together, we're going to end up with 80 grams per mole. Now we have to solve for X, so it's just simple cross multiply. 3.45 times 80 equals 1X. X equals 276 grams of ammonium nitrate. All right, in this one, they want us to make the correct numerical setup. That means we don't have to solve it, but we have to show our formula and we have to show where all the numbers go. They're asking us to calculate the number of moles. Oops, I didn't lock this in place. The number of moles. So the first thing I do is I write down my formula. Moles equals grams over gram formula mass. Then I go hunting and I say there were 11 grams of carbon dioxide. That's going to be this number right here. So I'm going to put the 11 where that number is. The gram formula mass for carbon dioxide, I need to figure it out. So when I figure out the gram formula mass of carbon dioxide, that's hard to read there, it's 44 grams per mole. And that's going to equal moles. That's what I'm looking for. So this technically is my answer right here. the correct numerical setup. If they asked you to solve it, which sometimes they do, you're going to do 11 divided by 44, and you're going to get 0.25 moles of CO2. All right, in this question, this is the last one on this page. It says, what is the number of moles present in 52 grams of NaNO3? They gave you this big song and dance up here about sodium azide decomposing to inflate airbags. On impact, the sodium azide is ignited by an electrical spark, producing nitrogen and sodium. The nitrogen inflates the bag. None of that matters, okay, in this particular problem, because all they want to know is the number of moles. So we're going to write our formula. Moles equals grams over gram formula mass in a 52 gram, that's the given